Okay, so let me welcome everybody. Let me welcome everybody to this webinar. So the background to this is that Fabio is preparing a proposal, and he's going to present kind of where he is now in terms of thinking about what to do, where to go, and the objective here is to get him feedback. So that's really what we're here to do. So Fabio will present his ideas, and then again, I think the main objective that we have is to help him kind of improve, make him aware of things where, you know, things need more work. So maybe the best way to think about yourselves here is as referees, and that will help the process along. So Fabio, over to you.
Thank you very much. And I'm not gonna spend other seconds because I know we have this long presentation to go. So I'm gonna share the screen, and hopefully you may just tell me that everything is fine. You can see it, right?
Everything good.
Okay. So thank you for the introducing this webinar, and this is really true. This is not at all a seminar that is presenting results, but indeed is a seminar that is trying to share with all of you a proposal of a long-run research agenda, and therefore everything that you may think of that I've missed or I should twist in a better way, or anything that you think that is useful to improve this research agenda is much more than welcome. Let me be very brief in introducing myself. I'm going to be super brief on that. I'm currently associate professor at the University of Foggia, but also research fellow at Marie Curie at the European University Institute. And I'm also following the debate on agricultural trade policies, and I'm currently chairing the committee of the ITRA consortium. I got an education in agricultural science, and then my postgraduate education is in economics in Italy and the US. As you can see, I'm trying really to focus my research agenda on climate change and trade issues and on trade policies. That is actually the focus on some of the projects that are ongoing that I'm actually supervising. There are some publications that I want to highlight, but they are not really particularly important at this point. So let me go immediately to the point of the speech of today. So this is a long run agenda. So you have to think about this as a 5 years agenda, research agenda. So also give me feedback on feasibility of this agenda and possibly addition within this time framework, but don't be in some sense surprised that I'm going to present several issues that I want to address with this. So this is a research agenda that goes through 3 components or 3 steps, but they are going to lead actually through a unique goal. What is the unique goal? Actually, we are in the framework of climate change. Climate change, we know that is impacting agriculture and is also impacting trade. The problem is that we know little actually about those mechanisms. We know a lot about agriculture productivity and climate change. We know a little bit less about climate change and agricultural trade. We know even less about climate change and agricultural trade policies or environmental policies. Why this is very relevant is because actually if we understand those links and we connect those to the EU context, that is going to be extremely important for the policy debate and for the agenda that EU is planning for domestic policies and international policies. So let me immediately say what I believe that are going to be the contributions of this long-run agenda. So those are 3 steps. The first step is on climate change, agriculture production, and intra-EU trade. This is, as I said, is going to contribute from the scientific debate. Actually, there are studies that have emphasized how climate change is altering agriculture productivity, but due mainly to the limitation of data, those studies are not related to the European Union. Mainly, they are focused on the US. So this is per se an addition, and is also in addition the fact that I will investigate exactly the links between climate change and agricultural trade. Again, there are some studies, but the evidence is not broad and is not even consistent. The policy contribution of this first step is to inform the political economy of climate change agriculture in the EU, because climate change per se is also altering the agriculture production, and therefore there are member states and agriculture sector within a member states. When I talk about agriculture sector, I mean actually type of products that are going to be affected, and therefore this is going to create not only political tension, but just political interest that may be different and heterogeneous within the European Union. And of course, there is a societal contribution that is related to making awareness to EU citizens about the evolution the agricultural sector is having just because of climate change. But this is only the first step. The second one is focusing on EU in the context of world trade. And in particular, I'm going to focus on a specific issue, that is, what is the impact on environmentally related trade policies on the agriculture. This is not entirely new in the sense that trade policies are under the spotlight, but there is not much detail on the agriculture sector, in particular on the technical regulation and the provisions that are usually used by economies such as the EU. So this is per se a scientific contribution that is important. As I said, that there is a relevant paper by Shapiro. I'm going to talk about that later on. But there is also important in terms of policy contribution, because it's going to give insights on the policies that are more or less efficient, and trade partners that are more or less affected, or sectors that are more or less affected, and therefore is informing the policymakers actually on what is behind those policies from a very macroeconomic point of view, in some sense, because I'm going to use aggregated data, so I'm going to use the data on trade flows. This is going to basically the meat that is going to feed the main lunch, and the main lunch is the political economy of international cooperation. This, I believe, is super important because it's go much farther with respect to what I've talked here. The point is, trade and negotiation are actually redesigned and are trying to be redesigned in a way that is very particular. Trade policies are trying to be redesigned so that policymakers care about important issues, such as, for instance, climate change. So the point is trying to use trade policies and international cooperation to reduce the pressure on the environment. So why understanding the political economy of the international cooperation is important? Because this is helping policymakers designing the future domestic and trade ag policies. The timeline is also extremely important, I believe, because actually we are just in the process of starting the new common agricultural policy, but this is going to last till 2027, unless there further increase in the timeline. That's not actually the focus of my speech. The point is that feeding the policymakers with those information related to what are the impacts of climate change on the agriculture, how trade is changing, and what are the trading partners that are affected by those policies and the provisions, is very important to redesign the common agricultural policies after 2027, but also negotiating new cooperation agreements that are debated at the global level. And of course, this is also a societal impact that is very relevant in my sense, because it's going to prepare citizens to changes that are going to be really large to transit actually the agricultural sector, the EU agricultural sector, toward a greener sector. Now, this is, as you can, I hope I have conveyed, it's a pretty long research agenda. So some of the things that I'm going to talk here now, I'm going to be much faster. So what is the first step? The first step is understanding climate change and agriculture. This is not new, as I said, but what is really striking when you compare this graph that is actually related to previous analysis that are roughly 15 years ago, and the next one is that climate change is impacting agriculture productivity, but what is more important is that you need actually refined data to find the changes in agriculture productivity that are not only at the country level, but are really related to a much more disaggregated level. And there is much literature on that. I want to mention the work by Bruno Conte and Esteban Rossi Alsberg is publishing on ADR and Journal of Economic Geography. The whole story is that you need actually, or David Lobel actually with Stanford, actually you need refined data to find the relationship between climate change and agriculture. Also, it's not just agriculture productivity, so it's not just production or yield that is important, but also the land uses. So it's not only the fact that you are producing more or less in terms of yields, but also the use of land is changing. This is important because it's reshaping the sector. Now, this is a paper just published in Nature, and as you can see, Europe has a peculiarity, has changed multiple times the destination of land. So what it's just saying is that agriculture is really impacted. Those are changes in terms of pasture, so using land for livestock, crops, urban, and all these possible destinations. There are 6 in a way. And you're seeing that multiple changes really occur in Europe. The only explanation that I may say that is quite simple to say is that Europe clearly has a scarce land, so the use of land is very important in this case. Now, these are the stylized fact or some evidence that I just said. So again, climate change is altering productivity. Their works I'm gonna link my analysis to is changing land use, is changing country specialization. What is important is that you need data to show these. You need data to understand those phenomena. As I said, recent work, for instance, and then I promise I'm going to go to the proposal and itself, really to research question, is a work by Conte and other co-authors, including Rossi Ansberg. So they actually show that the agricultural output is changing. If you compare the top left and the bottom right, you are going to see that the world is going to change if they compute a simulation over a century time period. And if you compare what's going to happen in terms of agricultural output with and without climate change, you're going to see that the impacts are very much heterogeneous and are relevant. They are not necessarily good changes. It's not only positive changes, but also negative changes. Another point that they actually are pointing very much, and they are extremely good in doing that, is that the whole point of this relocation due to climate change is the switching costs. So now they use trade costs to show that basically you do not have any change, or you have a little change if there are high trade costs, if the switching costs to move from one sector to another sector, or to move production from one side to another side. So if those trade costs are high, basically the switching among those productions and sector specialization are pretty small. But if you look at what's happening again in the bottom right part, then the low trade cost means that imply that these changes are much more relevant. Why this is important is because I believe that apart from simulation, this is a brilliant simulation study, you need an environment that is controlled, where actually the switching costs are low if you want to address those changes in a different way. Now, why I focusing on agriculture sector in Europe, and why I focus on the trade of agriculture, of the agriculture sector. Now, other few things before moving on the real meat of this lunch. So first, intra-EU trade is important, and I think that you can see immediately from the graph that is on the top left, where you see that actually 60% of the export of agricultural products is within the EU. So actually, trade is relevant in the European Union for agriculture sector, but it's really relevant within the EU. So there's really, it's not just a diminution, it's not diminishing the relevance of the work working within the EU. It's actually very important. There are more data that you can use to address those issues, but this is really capturing 2/3 of the phenomenon. But also the export, the extra EU is increasing as well. As you can see in the graph that's just in the middle, import and export outside, so the extra EU trade of agricultural products is increasing. So this is important to understand the story of within the EU. It's important to understand what's happening in terms of trade when you look at the European Union in the context of the globe. Also, if you look at the member states, it's not really trivial to say that member states and sectors are different across Europe. Look at the slides that is actually in the bottom left. You see that over time from 1961 to actually 2017, just looking at countries, you see that there is movement in terms of emissions from the agriculture, and is not moving over time, is also different and heterogeneous across sectors. Why I'm stating this? I'm saying that there is a lot of movements of agriculture goods within the EU, and this is relevant not only for the sustainability of the agriculture sector of the EU, but also in terms of impacts on trade, because moving a production from one member state to another member state does not necessarily mean that this has a zero effect on the environment. So now that I hope I've convinced that this is relevant, this is important to focus in the EU, not just because we are at the EUI, but really because there is relatively much little evidence on the EU, but there is a strong importance of that, strong relevance. I'm saying that I'm gonna discuss these 3 steps. So step 1, climate change, agriculture, production, and intra-EU trade. Step 2 is trade and extra EU trade and trade policies. The third and the last, the most challenging one, is how these information are going to feed the international cooperation that is moving ahead during these years. Now, first thing first, whatever you have to do, actually, you have to build data. So you have to do science with scientific evidence, and therefore what I call step 0 is not really step 0, it's part of the project, is integrating data sets that are publicly available that give me the possibility to go into the detail of the problem. So there are 2 steps within this construction of the data set. The first part of the data set is really feeding a step 1, so climate change and agriculture and intra-EU trade. So I don't need anything about trade policy at that point. And this is relating, basically is devoted to integrating the data on temperature, maximum, minimum temperature, median temperature, precipitation, evapotranspiration, global radiation. So everything that actually, thankful to my knowledge of agriculture science, I believe that is important to model the changes in agriculture productivity and land use. The second thing is to look actually at the production, harvested production, livestock production, and the area on production, and also on other important things like firm performance and prices that the TBD actually is going to be replaced, because I know exactly what I can pick that from the Eurostat and the FADN. Those are publicly available data sets. And then I'm going to use trade data and emissions data. So data on import and export and value and quantities and emissions that are provided by the FAO. The second step that I want to just anticipate is introducing within this data set the trade policy, and in particular NTMs and provisions that are related to the environment. Now, the way I decided to explain this is a mix of econometrics, intuition, and a very extremely simple graphical representation. So I hope that you'll not be offended by the extremely simplistic way to show this idea. or at least to me, that's extremely simplistic. So this is what is all about step one. We have European Union, and there's red arrow are saying that there is climate change that in some senses an exogenous factor that's influencing the European Union. And therefore, with the data set that I'm building, I'm going to use 42 years of weather data. So I'm going to compute the rolling average of climate normals. And I'm going to use also annual and regional production data of livestock and crops for different crops and different livestock. I do have actually the disaggregation to do that. And then I'm going to use the information on cultivated area at the regional level to answer the first question. So how this is going to be done? Actually, as I said, this is the chunk of the data set that I'm going to use. Those three lines are highlighting the homogeneity of data that I can use to address this. And therefore, the point is, what are the climate change impacts on EU agriculture products? The literature is actually vast, as I said, it's still very vivid. This is actually an evidence of the fact that there is much more to be done. But the studies that I've shown and I've mentioned, for instance, Lobel and Orsi-Bobea, they are in the US. Again, I don't want to repeat myself, but the story is just simple. We do not have the same amount of information and detailed information that is actually available in US. But we are actually going in the right direction with this data set that I'm going to use. The data on the weather coming from relatively new data sets, the agri-forecast of the GRC. So what's the idea? Outcome variable are going to be modeled as a Blankenschlenker, among others, are suggesting. So outcome is going to be a functional in a additively and separable functional form of the weather condition. So the whole idea is the weather is impacting agriculture productivity and land use, and this is actually emphasized using this econometric approach. Now, there is a problem that has been recently highlighted by Mendelssohn, not only by Mendelssohn, is that climate change is actually a long-run phenomenon. So it's not just the impacts that you observe in the short term that really matters, but also the long-run effects on climate that you observe that matter. And as Robert Mendelssohn, the Yale professor actually that is very much focused on these models as highlighting in a working paper that has presenting around, is that it's not extremely trivial to disentangle short-run and long-run effects. He proposed this model that he showed that is actually the best. I'm not saying that I'm going to use this exactly because it's the best. I'm going to show that this is very relevant, and I'm trying to disentangle the short-run and long-run effect. Exactly for one reason. We do not only need to know what are the impacts of climate change on the agriculture sector now, but we want to know what is going to likely to be the sector in a few years from now, because actually we want to be forward-looking when looking at the policy-relevant questions. So what is the output of this? Actually, the output of all these exercises is to understand the changes in production in areas due to climate change, but those are going to be disaggregated by member states and products. And those are giving winners and losers. So without any type of intervention, what the climate change is doing to agriculture and how is actually reshaping just the use of land and the production in agriculture. This is a very relevant question. Now, as I said, this is one part of this exercise, but as I said, the data that we have from the agri-forecast, daily weather data simulated for the crop, go up to 2030, so they are also going to be useful to forecast the changes. So we know the parameters of short and long run changes in the model, and using data on forecasts changes in 10 or more years from now is going to be very important to understand how the sector is going to look like in the future. Pros and cons of this analysis is, let me just say, if you want to interrupt me, if you have questions, that's fine. Just going, trying to go fast, and precise to just be on time. So pros and cons of this analysis: lack of empirical evidence on the EU, but little comparability for validity check, in the sense that, as I said, this is actually the bad side of having relatively little studies on this. Now, the other thing that I'm gonna focusing on is the impacts of climate change on trade. And in this respect, I'm gonna use a conceptual framework that I'm using, and it's not only me actually is using to understand why climate change is altering trade. This is really related to the export. So the short story is that, as Mendelssohn and Nordhaus have shown in the AAR paper, climate change is impacting production. So it's shifting the production, and therefore you may actually connect climate change to the agriculture production. But supply is, when it's in excess, actually it goes it goes out in terms of export. So the excess of supply in this framework is actually modeled as function of climate normals. Now, there is, as I tried to say, there is an important problem with this, and that's possible why many studies have actually looked at the simulation. So not looking at the econometric side, is that you're trying to model something that is really relatively increasing the climate. So actually you are using, if we were using data for a century and a half, we would have quite a bit of variability, but we are focusing actually, as you can see in this graph, on a very limited part. So the slope of this climate change is limited, and therefore exploring what is the impact of climate change on trade is very difficult, because there may be some other trends that are going on within this framework. So what's the idea? The idea is to focus again on just the EU, because this is going to be a controlled environment. So it's going to be an environment that is protected, because there are no trade policies. The trade costs are going to be relatively little, because the movements of agriculture products within EU is within a limited amount of distance. So products are going to be actually moving for relatively little kilometers, and there is the same currency. So all this is saying me that the influence that can come from outside is just removing. This is going to be actually a natural experiment. So when I'm talking about like changes in the trade policies, there's not going to be a problem. Changes in outside policies, exchanges rate, or just movements in terms of the cost of fuels for long distance is going to be very important if you look at the outside EU trade or long distance trade. And especially important for those products that may be highly perishable or low perishable, so very heterogeneous. So focusing on that, I'm going to use 42 years of weather data, the same data that I used before, and the annual and country level trade data in terms of volumes and quantities to understand what is the impact of climate change on EU agriculture trade, so intra-EU agriculture trade. What type of approach? This is relatively new. We're using in a much in a different context actually, but in this paper that in this working paper I'm working on actually with much more aggregated climate data, and this is related to 20 countries. Is not even related to this context. I believe that is indeed much more important to look at data on climate data that's much more refined, because this is capturing implicitly better this idea of trade being related to production, exactly because it's an excess of it is a surplus, so it's an excess of supply. Where these basically come from, again, is the Mendelssohn idea in AR. So the idea is that production is related to climate change, and we are only adding the part of excess of supply being considered export, and therefore trade being impacted by climate change. But I don't want to go into the mechanics of this too much. The model, of course, does not necessarily need to be this, but it is at the core of the model. So export is going to be related to climate change. But of course, if there are questions, I'm happy to answer. The other thing that I'm going to do is actually to look what are the intra-EU bilateral movements, because this is informative actually when you impute the climate normals within this structural gravity model idea. What are actually the impacts of climate change on bilateral trade? Again, why this is relevant, apart from the mechanics of this econometrics, is a simple econometric model. The mechanics is important because this is telling me with these climate change dynamics that are evolving, how countries are behaving, and in particular, who is winning, who is losing. So who is actually living out the production of certain products and who is taking that production within the EU. So it's actually telling, so let's go and make a step forward. Let's go and think really out of the box. This is telling basically whatever you are gonna think at policies that are gonna try to fight climate change, reshaping agriculture production, where you may find frictions, who are the member states, who are the sectors that are more or less affected, who is winning, who is losing. This is very relevant from the policy point of view, because as we know, the process of making a new regulation is complex, and in a democracy, everyone should be, or most should be better off by this. So this is actually telling the mechanics of that, and basically it's giving actually scientific evidence. So I have already anticipated this. This is important because changes in trade due to climate change are really impacting the EU member states, are really impacting the products level. So this is taking, is giving the geography of impacts of climate change within the EU, and therefore, without any type of intervention, what's going to happen in terms of the political debate. Again, those models give give an important give another important addition, because you can easily use those data that are available and very detailed, provided the agri-forecast, to actually simulate impacts in even a few years from now. Again, why this is important? Because we are going to debate on, for instance, the common agricultural policy. This is going to be debated in 4 or 5 years from now. So this is going to be very relevant because it's going to be informative on how the sector is going to be reshaped. Pros and cons I've already discussed it in some sense. The pros is that I believe this is a very much a controlled framework, same trade policy, low transaction costs, no exchange rates. But the cons of this is that the partial analysis, there is no external validity. So I believe that this is very relevant for the European Union, but not necessarily true for all the countries. This is, of course, a limitation, but as I said, that I have transparently said at the very beginning of the speech, here the main focus is the EU, and the EU is the main actor that is going to be important in all single components of this long-run project. So now, a little piece more that I want to add is what are the environmental costs of these movements of goods. This is relevant because actually, whenever you move agriculture products, is not just reshaping the agriculture production and land use, but this has an impact actually on environment as well. And as I said, looking at this as in a controlled environment like the EU gives me the possibility to exploit a lot of more data that would not be available necessarily at the global level. What's the added value of this? So I'm going to look at the trade within the EU and the emissions. What's the added value? This is, as I said, it's not completely new. And if for those that are familiar and very passionate to this studies, you know that Joe Shapiro has just published a paper in QJE that has basically done a lot of things. He has done shown that there is an environmental bias in trade policy, has looked at the tariff, has looked at the NTMs, it is disaggregated by sector, but actually it does not go too much into details. And what I'm suggesting here is to look at the EU in a much more refined way, looking at an even more disaggregated levels, and not just considering the agriculture macro sectors, but looking really at the very much detail. It's important in order to do this, I need something more. I need to compute the emissions intensity. This comes from this formula. So is actually emission factor, transported tons, kilometer driven of fuel use. Those are available. And there is one thing that is very much simpler than what is usually done for extra EU trade or for global trade. It has usually, you may think that the modes of transport are much less when you talk about agricultural products being shipped within the EU. Basically, you don't usually use first-class airplanes and you don't use cargoes because the distance are relatively short. And so this emissions intensity is going to be relatively easier to be computed. But there is also another point that is very relevant, is that the details that I have is not only related to the CO2, so the main greenhouse gas emissions that is studied, but is also related to the CH4, so the methane, and to the N2O. So the other components that are very relevant in agriculture. And preliminary studies, preliminary funds, preliminary analysis that I've seen says that those are correlated, but it's not necessarily true that whatever you find for the CO2 apply to other pollutants. And therefore, you cannot just take the evidence on CO2 and translate, assume that everything is working the same. It's not going to be like that, actually. So what's the mechanic? The mechanics here comes from Shapiro, AEJ paper. He computes the trade embedded emissions. It's pretty simple. So the emissions that are due to the trade that the destination country is having. So basically, whatever you import is actually related to whatever you are emitting in the production phase and when you move these goods outside of your country. So basically, as there's gamma, and then the K, the key, actually there's a Greek letter, the key origin is actually the emissions during production, and then you multiply this by basically whatever you trade, that XOD from the origin to the destination with respect to whatever you have produced. So it seems complicated, it's really simple at the end. It's actually, I've computed some of this to have a rough idea. So basically the idea is in agriculture, you produce, you emit basically when you produce the good, that is exactly when you make these emissions. But if you have to trade this good, the problem is not necessarily the transport that creates problem, but is the fact that some countries, again, may have emissions intensity in production that are relatively different, much higher or much lower. And therefore, it's not necessarily true that specializing a country is always good. It may be good from the economic point of view, but not necessarily from the environmental point of view. I'm not saying that I'm against specialization. I'm just saying that evidence on that will be useful to understand what is the environmental impact of this reshaping process of the agriculture sector in the EU. So what are the output? Compute the environmental and intended consequences of climate change induced in trade, disentangled by crops and pollutants, as I just said, and then forecast the changes to climate change, use simulation from previous step. Of course, you may have asked yourself why actually there are these orange color. These are the most challenging steps that are not necessarily within the research proposal, but I will do if allowed. So this is the first step only, and then I have the second one and the third. So let me skip this and gonna go pretty faster. I have already discussed that step one and step two are building from this data set. Let me see what happened now when we open trade to the globe. So actually, I'm going to use agriculture trade data for the extra EU trade. And here is, I believe, the important addition of this for the second component. I'm going to specifically look at the environmental related NTMs and the environmental provisions in PTA and RTAs. Why? The idea is pretty simple. We know that there is an environmental bias of trade policies. So there are tariffs that are relatively higher on greener products and relatively lower on dirtier products. The impact of technical regulation is important. Shapiro has mentioned, hey, we should study this more in detail, but actually it does not go into detail of that. So the idea is now we're regulating on the environment. So we're putting regulation and we're even putting provision. So we're trying within trade agreements to put regulation that are telling, okay, we're good, we want to trade, but we want to care really about the environment. So that's exactly what I'm going to focusing on. So I'm going to focusing on what is the economic impact of these environmental NTMs and the environmental provision. So I do not want to understand every single mechanism, of course, but the idea is if you have implemented an NTM for a specific product, so within a TBT mainly, and the SPS is just important for the agriculture, or if you have imputed provisions for the environment, what is the economic impact of that? This is important because it means that I have a matrix, I have a mechanism to understand whenever you implement this regulation, how worse or better off you are. The mechanics is pretty simple. The literature that is very, very large by Yolton Freeman. So actually is suggesting how to use gravity model to estimate those ad valorem equivalents. So I'm not going to struggle too much because there are data to do that, and there are very solid methodologies to do that. Again, why this is relevant if it is just solid? Because actually it requires to go into detail of these trade regulations. So it requires to use disaggregated data that we have now at the sector level and for the environment. There are several that are mentioned in the paper. Now, those are the effect on the economic side. Why those are important? Because if I impose a regulation and they are really affecting economic terms, this is a problem because that means that you have a credit. I mean, if I impose a regulation and you are affected, I have a credit, I can actually ask something you in charge, in change of removing that very detrimental policies. But as I said, this is only one side of the problem. The other side of the problem is what are the effects? Okay, those regulations are there, but they are not to restrict trade. That is not the main idea, at least. That should be there in order to protect the environment. So the idea is what is the effect that those type of policies, so NTMs and provisions, have actually on the environment. The idea is to use, again, the approach that Shapiro has suggested, but is adding, because as I said, it's going to be much more refined. It's only looking at NTMs and provision in the agriculture sector. So I'm not going to discuss again the EJ term, that is the trade embedded emissions for agriculture products. Why this is relevant? The output of that is that change, I can compute the changes in trade values with EU trading partners due to environmental policies, and so understanding who is better off, who is worse off. I can also understand what is the environmental impact of this regulation, and therefore how trading partners that are implementing or that actually need to obey to the regulation that the EU is imposing are changing their emissions in terms of are changing their emissions, so the impact on the environment. A related aspect to this is not necessarily looking at the emission leakage, but it is going to be actually an easy way to add another step to alert on potential emissions leakage threats. What is the idea? It's extremely simple. If I know what is the environmental effects of those trade policies, just looking at the trade changes, so new routes to trade diversion, trade creation, or increase on decrease on change, is actually inferring, is giving an inference on the emission leakage trade. So basically, hey, there is a problem because that policy is very good, but then is potentially leading to an emission leakage somewhere else. Again, EU is the main player, so I'm only looking at EU and what's happening in terms of extra EU trade. So inflows and outflows trade of agricultural products in a bilateral way. The last things that I'm going to do in this second component of the project is to look at what is the impact of these policies within the EU, looking at the value chain. There are a couple of issues here. The one is that, as I said, if you want to understand how trade regulation, trade negotiation are going to give, you want to know actually who are not only your friends and your enemies outside of the EU, but also who are your friends and enemies within the EU. As I said, climate change is impacting agriculture, but trade policy is impacting agriculture member states also. So the idea here is to look at the same set of data, so trade data, environmental related NTMs, environmental related provisions, but also look at the farm economic performance from the FADN and agriculture products and agriculture production data. Why? Because I want to look at two things basically. The first thing is how the value chain within the EU is changing. So basically, if the participation to the EU value chain is altered by those policies. Why this is important? Because in agriculture, there is a really a crucial issue. I do not have an idea if this is only related to agriculture, but in agriculture we know this pretty well. So much of the margin do not go to the farm level, but they really go to the process industry. And therefore, if those policies are changing, who is taking those margins? That's again is a problem. And this is possibly to be done using the trade data for the raw product, intermediate, or more processed products that are the higher added value. So again, the idea is to look at how the value chain participation within the EU is changing for members and for products of the EU. And the other thing is to look at the economic performance, because as we know, those policies are not only potentially problematic in terms of emission leakage, but also in terms of domestic competitiveness. And therefore, this is exactly what I want to have an insight on. So I'm going to use FADN data, that is a survey that using representative farms and economic performance of those farms. So, for instance, production costs and quantities, or the production yeah, as I said, it's production quantities, production costs, or economic performance, like the profits, but also the prices of those products within the member state using the Eurostat database. I'm going to relate those economic performance with those policies that are implemented, so these NTMs and the provision on the environment. So again, this is actually saying, okay, there is this big problem. You have friends and enemies outside the EU, you have friends and enemies within the EU, and you know all this, or you have this evidence that is very informative to understand who you may want to dialogue with, who is going to be likely to be opposing to certain type of policies, or is going to favoring those policies because is going to be better off because of that. So, as I said, this is assessment is going to give an assessment of potential threat of ag value chain disruption, so potential problems with the agricultural value chain. So the need to actually import from extra EU, or is going to give an evaluation of potential competitiveness and loss, and is also giving the possibilities, not necessarily to be done, to stimulate the effects of removal or adding an environmental regulation provision, and also, as I said, alert on potential tensions of interest groups. Now, I'm not going to spend much in saying why this is relevant in terms of scientific contribution, policy contribution, societal contribution, because I think I spent a little bit of time already on that. Why I really want to go into the third step, it is more challenging. It's less defined, even because it's much further and much farther in terms of time. And here I really which I can try to use a set of new ideas that come from Sibel Uckman and the debate actually on moving from regulation that are unilateral, bilateral to open plurilateral cooperation. So the idea is actually whenever it comes to climate change, and this is not necessarily only related to climate change, indeed, is true for many other aspects like digital trade, we know that basically you want a different type of cooperation. Now, humbly, I don't want to, I'm humbly discussing this, but you know, once you are in front of the author of this thing, so you don't want to talk too much. So I just want to emphasize that there is a recipe that they are giving in order to make this open plurilateral cooperation working. And so the idea is, as you see, and I have quoted this, it's important to have a solid evidence-based scientific evidence. You actually need to have communities that are informed and can tell you exactly how these mechanisms that you want to input within these plurilateral cooperation agreements are going to work. Now, with this,
Fabio, sorry to
yes,
interrupt, but if you want to keep some time for questions.
Yeah, I'm gonna end in 2 minutes.
Okay.
So thank you. Sorry. So I'm going to go even more straightforward on that. So supporting evidence on the cost of agricultural trade policies. I'm going to use scientific evidence using a meta-analysis on two important things: local pollution regulation, for instance, pesticides or fertilizers. Just a meta-analysis is going to give you the estimated impact. So I'm going to rely on the literature on that. On global pollution regulation, so the impact of policies in terms of emission. This is a pretty straightforward meta-analysis, becoming very much a workhorse in economic analysis as well. So I'm not going to discuss that into the detail. Then I'm going to work in selected countries, so major EU trading partners and top emitting in the ag sectors, because the idea is to focus with these stakeholders actually to gain more information. This is the approach with the expert, but also there is a desk analysis that is important. So using descriptive statistics for the ag sector, production, consumption, labor force, structure of incentives. So all this is going to be informative and say, okay, the results that we have produced for the EU, how they relate to other major countries that are going to be the partners of these cooperation. And as I said, I have anticipated that the last things is actually to engage with the stakeholders that are going to tell on the policies and private initiatives, and also they are going to inform on what is needed in order to put those regulations in practice. Why this is important? Because as they show in this, I would say, very great paper, and also David Victor and Charles Abel saying in their book, it's not easy. You need actually to use an approach that is not coming from the top, but is also relying on the capability of countries to use new ways to emit less. As I said, I was very transparent in saying that this is not super defined, and the reason is actually that this is in 3 years from now plus is the most challenging part that, of course, is going to be fed by the component 1 and component 2. And I hope I promised with this to be on time. So I really thanks Bernard for warning me on that. Thank you very much. And any comment is very appreciated.
Okay, thanks. Can you stop sharing?
Absolutely.
Great. Okay, so the floor is open. I think one of the things that really would benefit Fabio. So one, there's a question: can we share the slides? I leave that to Fabio.
Yeah, I think
you know, kind of just not just questions specifically, but kind of an overall sense of, okay, does this hang together? So feedback, basically, I think is what Fabio is looking for, but also potential areas in which, you know, there's a hole, there's a missing link, whatever. I mean, it's really kind of open, very much open. So I encourage everybody with views to chip in. So let me know if you want to. Who wants to kick off? Okay, Camila.
Okay, so hello to everyone. And thank you very much, Fabio, for the presentation. At least for me, I'm an economist, not that much familiar with the environmental issues and interested in those issues. So it was very good for me. I learned a lot. And so it was a lot of information. So I was trying to organize myself to make some comments. But I think my focus will be on, I felt a little bit missing issue about technology and new technology. So you mentioned a lot about, especially at the end, you mentioned the role of environmental policies or regulations. And of course, this may trigger the new technologies, and as well, the impact of different technologies on emissions and so on. So I think the word technology for me was, okay, so is there a place? Maybe there's not, but it was something that I was thinking about. So how somehow the technology, new technologies impacted those issues, and also possibly trigger new technologies, right? Regulations and so on. Okay, so I think that was my main point. It was very interesting, and it was a lot. So I would also benefit from the slides to organize my thoughts as well. Thank you very much.
Thank you very much. I'm gonna be fast so that if there are further questions, good. Yeah, it's a great point. I think that I want it to be feasible in this. So I believe that there is absolutely a role for this. This is going to be on the third part. It's actually where I believe that we want to put that in. So knowing exactly what are the available technology at the EU or in other member states, so that we can actually find the feasibility of cooperation that includes adding new technology. And the reason for that is, as I said, is mainly due to the availability of data on that. So I don't want to plug something that is unfeasible in the econometrics. But I'm going to check if that is feasible also within the other steps. Thank you very much. That's very important.
Yes, if I can comment on that, of course. So in terms of technology, possibly it's more, it's easier to find data on case studies or this sort of, so it was completely clear what you're going to, everything that we're going to produce. But of course that in some specific case, of course, it's better, it's easier, right, to try to accomplish that with either case studies or a few countries and see. But then you can use that output to infer or to draw policy implications.
Yeah, okay? Absolutely. That's exactly why I think that the third component is the natural home for this point. I should mention this very explicitly. Thank you.
Who else? I see Filippo making movements. Nope. Okay, well, I'm not going to chip in here because we're going to speak bilaterally after this. So that's not going to be, we'll do that. We'll do that afterwards. So no other suggestions, questions, quibbles?
Maybe Ariana has opened the microphone.
Maybe I can ask. Maybe I can ask something. But we've already talked about this bilaterally. But I thought it was very interesting how you pointed out how you're going to use your model to also estimate or predict the political economy dynamics that are going to come out of regulation. And I was particularly curious that you focused on a country dynamic in the first step of your presentation, and then you moved to a value chain approach. And so I was wondering, how are you thinking to combine these two things? No, so the political economy incentives that are going to be created at the country level with the different incentives that might be created for different actors along the supply chains.
Yeah, it's a great point. So the short it is that those two components are basically trying to tell me who is winning and who is losing. And in the first part is really much related to the impacts of climate on the agriculture production. So I don't want to make a step forward and saying, okay, but also the process is impacted because I don't trust in this. Actually, industries are not really much affected. But whenever it comes to the second part, then trade policies, they may have actually an impact because they actually may alter the capability of EU of having inputs of raw products from outside. So the idea is to exploit the fact that I have data, trade data for raw, intermediate and processed goods, so to understand who is benefiting more or less along the value chain. So the short answer would be it's all about trying to understand what are the tensions that are implied by the climate change at the very primary sector level, and what are the impacts of environmental regulations that are trying to fight climate change along the supply chain. Because in both cases, actually, you have stakeholders that are going to debate in Brussels, and therefore you are going to have different tensions that can come from different parts. Not necessarily true that industry is the most important part or vice versa. So I am trying to have a bigger picture on this, because at the end of the story, let me conclude on that. At the end of the story, when you redesign the CAP, that is going to be integrated with the trade of agriculture products, and therefore, if you are going to decide something to protect the agriculture sector, you cannot dislink this from the processed phase. So that's the idea.
Thank you.
Yeah, very welcome. Thanks. Thanks very much.
Fabio, there's a question in the chat for you.
Yeah. Description of the variable stated as environmental provision in PTA, or is it a damage or measured out? So that's a very good question. So the idea actually here is to use existing data set that are, for instance, DASTA or the World Bank database. They are just saying what type of provisions they have. So the short answer is that yes, they have already been coded as dummy. That says basically what type of environmental issue you care about in these provisions. But the analysis of those documents is something that I want to do as a part of the component 3. And I didn't actually mention that, but yeah, the short story is that yes, I'm going to rely on those data sets that are already available. Mainly, those are dummies. Basically, they say what the provision has, and what type of environmental aspects are regulated within this. I hope that is a clarification. Of course, whenever you have them, you can do many things. You can just see how deep is the provision and how that is different across countries. So yeah, it's dummy, but you can use in several ways. Yeah, thanks very much, and thanks for asking.
Okay, any other people want to come in? So on this environmental provisions and trade agreements and so forth, talk to Filippo, because as part of the Respect project, we've actually done a huge mapping exercise in terms of what is in trade agreements, what is not in trade agreements, what is enforceable, what is not enforceable. So I think the enforceability dimension is something that is important. And in addition to DESTA, now we also have the World Bank handbook on deep integration, which has additional information. So one question, and again, we'll talk after this. But I think one of the things that strikes me that's not really clear to me is to what extent is there kind of cross-country, cross-sector information that people have put the data together on what these supply chains actually look like. Right, so to some extent, that's just a question of what's the production function for a lot of these products. But obviously those production functions will vary across countries. So I don't know if so I think there's probably a lot of information on in terms of what are inputs, intermediates, the production process, you know, the whole kind of, yeah, you can think about that as a value chain. And I think there's a lot of sector specific analysis out there, but has anybody looked at this globally in terms of through a value chain lens as opposed to a production function lens? Because it wasn't really clear to me how you're going to do this value chain unpacking.
Yeah, no, it's a very great point. And of course, you know, I think that the added value of this project is not necessarily to go a lot deep into each single step of that, but rather having a much bigger picture on what is the impact, the specific impact on new agriculture. So the idea that I have having in mind is really to look at the flows of raw, intermediate, and processed food in the EU agriculture. So basically, the idea is looking if because of this environmental regulation, we are missing the possibility, for instance, to import Canada wheat from Canada and Ukraine, and how we actually may where the wheat can come from in order to produce pasta, for instance. So it's more about relating the inputs that you need in terms of raw food that they are going to be processed. And this is looking at this very recent work that are going to see participation in backward and forward participation in the value chain. It's I found this quite a simplistic way, but that's what I need actually, because it's just I need to understand.
Yeah, so I would then stay away from the word value chain.
Okay.
Because what you're really looking at is you're looking at input-output relationships. You're looking at, you know, inputs into a process. You're looking at, you know, so that's different. And then you can actually talk about either, you know, commodities or sectors, but we're not talking about the value chain, because the value chain is a different beast and it's much more complicated.
Yeah. Thanks. That's very helpful as all the other, because, you know, I need feedbacks. Thank you very much.
Okay, so we're over time. I don't see any other hands raised. So thanks everybody for tuning in, and to be continued. So thanks, Fabio.
No, thanks to all of you, and thanks to Bernard very much.